quadratic parent functions. In order to cut down on some of the length of the video, I've gone ahead and preloaded this first page. It is strictly informational, so please make sure that you get it copied down in its entirety before moving on. Notice in the linear function I used interval notation, and in the quadratic function I used set notation. That's just to keep us moving so we don't forget about either one of those. Alright, standard form and vertex form are two ways that you can identify a parabola. We'll go through the standard form first. Standard form is ax squared plus bx plus c. Concavity of a parabola is either up or down, determined by the symbol on the A, positive up and negative down. Axis of symmetry is located at a value. That value is x equals the opposite of b divided by 2a. You'll see this in practice a little bit later. The vertex is then located at that x value, opposite of b over 2a, and whatever the corresponding y value is as well. Add a second parenthesis there to complete the ordered pair. Again, you'll see this in practice in just a few minutes. There is a minimum on the parabola if the value of a is negative. There's a maximum on the parabola at the vertex if a is positive. Now, when we get into completing the square, you will see how to switch from vertex form to standard form. For right now, they are interrelated because they can both be used to determine the equations of a parabola. We will see this later on as how they are interconnected to one another by solving for one or switching it into the other value. Vertex form of a parabola is f of x equals a times x minus h squared plus k. This should be familiar to you based on transformations of parent functions. A is your stretch, h is your left or right movement, and k is your up or down movement. You're going to have concavity either up or down based on the value of a, positive or negative. Your axis of symmetry is a value located at x equals h. The vertex of the parabola is hk. So you can see why now vertex form is aptly named, because h and k will give you the vertex. Minimum at the vertex if a is negative, maximum at the vertex if a is positive. Alright, let's put this into practice with the remainder of these questions. Alright, for this one we're going to use set notation, and for example number 3 we'll use interval notation, just to keep us practicing both of them so you can recognize both. Alright, first of all, we recognize there is no stretch, so our critical values are going to be over 1, up 1, over 2, up 4. We're going to start at the value of 2, negative 1, basically transformations. Go over 2 and down 1. You're going to go over 1, up 1 from that vertex. Put your critical values over 2, up 1, 2, 3, 4. Put your critical values. If you wanted to go up 3 and 9, you could, or over 3, up 9, you could as well. There is a sketch of your parabola based on that transformation. Okay, so we went right, 2, down, 1. The domain is going to be all real numbers because this is set notation. Let's start with x. All real numbers. Your range for this is going to be y. Transformations. Negative 1 is less than or equal to y. Okay, you'll notice there is a vertical compression here, so we got to remember that after we transform this function from its center. So now we're left 4, down 3, and our critical values, instead of going over 1, up 1, we're going to go over 1, up 1/4. Over 1, up 1/4. Okay, over 2, up 1/2. Over 2, up 1/2. So on and so forth. A severely vertically compressed function. At this point in time, we have vertical compression of 1/4, left 4, down 3. Domain and range and interval notation, negative infinity through positive infinity. Range will begin at -3 and continue to positive infinity. Moving down here, we are going to determine all of these values for questions 4 and questions 5. Alright, so because the value 3/2 is positive, we are concave up. The axis of symmetry is located at x equals h, so x equals -3 is our axis of symmetry. The vertex is located at hk, so that is going to be -3, 6. Because it has a concave up, that it will have a minimum value. That minimum value is located at the vertex. The y-intercept is located and found by simply plugging in 0 to everything, to your x value. So that's going to be f of x equals 3/2 times 3 squared, which is 9, minus 6. So we're going to do 9 times 3, which is 27. 27/2 is what you have there. So f of x equals 9/2 minus 12/2. 9 27/2. I apologize for that. Because it's 9 times 3, which is 27. Excuse me. 27/2 minus 12/2. So that's going to be f of x equals 25/2. Sorry. Let's try that again. 15/2. Which is 7.5. So your y-intercept is 15/2, like so. Domain in set notation is going to be all real numbers. Range in set notation is negative -6. That's why I'm making my vertex wrong. -6 is less than or equal to y. Close your brackets. Okay, moving over, we're going to get right 3 down 6 here. Sorry, left 3 and down 6. And then we've got a stretch of 3/2. So over 1, up 1.5. Over 1, up 1.5. Up to 1. There we go. There is a slightly compressed, poorly drawn parabola. Okay, in this one, we have concavity, which is still up, axis of symmetry, which is located at opposite of B over 2A. So that's going to be 4 over 2, which is x equals 2. The vertex is also located at the opposite of B over 2A, so you're going to do 2. And now in order to find the y value, we simply plug in 2 for all of the x's. So it's f of x equals 2 squared minus 4 times 2 plus 5. So that's going to be 4 minus 8, which is -4, plus 5, which is 1. So that means the y value at the vertex is 1. It is still a minimum because the a is positive. Your y-intercept is still found in the same way. You're going to plug in 0 for everything. that is an x, and what's left is 5. So the y-intercept is 0, 5. Your domain, let's go ahead and do interval notation here, negative infinity through positive infinity. Your range is going to begin at the number 1 and continue to positive infinity, like so. Okay, so what you're going to do now is you're going to graph this thing based on all of these things right here. So I will go ahead and go over 2 up 1. And from there I will use my critical values. Actually, I'll use the y-intercept to determine if the critical values have any stretch or compression here. So I'm going to go over 1, 2, up 1, 2, 3, 4. Notice that there is no stretch or compression because that is a critical value. So I'm going to go ahead and fill in the rest of my critical values based on that. Okay, stretch and compression is critical, and that's part of the reason why y value, or the y-intercept, has been identified. All right? Please complete example number 6 on your own. Be ready to share and discuss it in class tomorrow. Moving on, question number 7. We are going to find either the maximum or the minimum value, and we're going to state the domain and range. Because a is a negative number, we are going to find your maximum. Because it is a standard form, the way we are going to find that maximum is by finding the opposite of b over 2a with the ordered pair f of opposite of b over 2a. So whatever we find for the x value, we simply plug it in for x and solve for y. Okay? So the opposite of b over 2a is 3 over 2 times negative 2. So that's going to be 3/4. So our x value is going to be negative 3 over 4. And now we plug in negative 3/4 to all of the x's to find your y. In calculating that, it turns out to be 41 over 8. Question number 8. We're going to sketch a parabola that has a vertex of 2, 3. So we go over 2, up 3, and has a point at 6, 9. So I go over 2, 6, and up to number 9. Okay, so that puts it right here. Now I have to do a little bit of critical thinking here. Remember that I have a line of symmetry here, which means that there is an identical point this many units away on the other side of this parabola. So that's going to be 1, 2, 3, 4. So I'm going back over 1, 2, 3, 4. Alright, now I have the shape of my parabola. If I go over 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, you'll notice now that what you have is a set of values that do not fit the critical values that are given on any particular parent function. So what we have here is a parabola that has a stretch or a compression. So what we're going to do is we're going to use vertex form of the parabola to determine what that stretch or compression is. X minus 2 squared plus 3. I've plugged the vertex into vertex form. I've identified that there is in fact a stretch or compression because this does not match critical values that are usually on the parent function of a parabola. So now what I'm going to do is I'm going to solve for a by using the point that was given to me as well. The point is going to be plugged in for x and y in the vertex form of the parabola, leaving only one variable, and that variable is a. So that's going to be 9 equals a times 6 minus 2 squared plus 3. So in solving all of this, I get a equals 3 over 8. When you solve for a, now what you have is your given value, and you can plug that back into your vertex form, and use that as the equation of your parabola. Question number 9. We're going to model a company's revenue here, where P is the price in dollars. At what price will we maximize the revenue? Well, remember, the maximum is the same as the vertex. So we're going to go ahead and find the vertex. Because it's in standard form, it's opposite of B over 2A and F of B over 2A. So B is 300 over 2 times negative 15. So that means I get 300 over 30. Negatives cancel out, which means that the y value, or sorry, the x value is 10. Okay? I don't need, oh, I do need it because it asks in the second problem what that maximum revenue is. Okay? So we're going to go ahead and solve this back out. Plugging 10 back into your equation, you're going to do R equals negative 15 times 100, that's 10 squared, plus 300 times 10 plus 12,000. And your maximum revenue on this would be 13,500. All right, our final example. Thank you for sticking in with me. I know these were long. Writing an equation of a parabola that is symmetric about the line x equals 10. So, x equals negative 10. I'm going to visualize what's happening here by drawing myself a coordinate grid system. So here's my origin, 0, 0, and here is my line, x equals negative 10. Now all that means is that I have a whole bunch of parabolas that can be lined up along this particular line of symmetry. Not very difficult once you realize what it is you're actually asked to do. All I need to do is come up with an equation of a parabola that could be on this line. Since vertex form is the obvious choice here, let's go ahead and use that. So we're going to do a x minus h squared plus k. The h must be the same. The h must be 10. So y equals a times x plus 10 squared plus k. Now, because the rest doesn't really matter, all we're looking at here are any set of parabolas that will fit the description along this line. I'm going to go ahead and make this one vertically compressed. X plus 10 squared, let's move it down 5. And you can pick out any one you want. It doesn't really matter. No compression or stretch this time. X plus 10 squared plus 6. The real value here is that you guys understand that the axis of symmetry is also the x value of the vertex of the parabola.